Hey everyone, in this video we will learn about Cmake. Cmake is an open source cross-platform build system that is designed to simplify the configuration, compilation and installation of software projects. It is widely used in development of complex software systems and is essential for managing the build process across different platforms and environments. It integrates platform-specific build files such as make files or Visual Studio project files from a set of instructions defined in cmakelist.txt files. It simplifies complex build configurations by allowing developers to specify project settings, dependency, and targets in a platform-agnostic way. Unlike traditional build tools that are often tied to specific operating systems or compilers, Cmake provides a flexible and platform-independent approach to managing the build process. One of Cmake's standout features is its ability to work seamlessly across various platforms, including Linux, Mac OS, and Windows. It allows developers to define their project structure in a platform-independent manner, making it easier to generate platform-specific build files without manual intervention. For example, Cmake can generate make files for Linux, Visual Studio project files for Windows, and Xcode project files for Mac OS, all from a single configuration file known as cmakelist.txt. This dramatically reduces the complexity of building software on different systems and ensures consistency across various platforms. Cmake excels at working wide a range of compilers and development environments. Instead of manually writing make files, Visual Studio solutions, or other build system files, developers can use Cmake to generate these files automatically. This allows them to focus on writing code rather than worrying about configuring the build system. By using a single configuration file, Cmake can generate the approach build files for multiple platforms and compilers, ensuring that the build process is consistent regardless of the environment. Cmake is highly customizable, allowing developers to create both out-of-source and in-source builds. An out-of-source build is where the generated build files are stored in a separate directory. Keep the source code directory clean and free from build artifacts. This is especially useful for managing different build configurations such as debug and release builds, without cluttering the project directory with numerous intermediate files. Developers can define various build options in the Cmake configuration files, specifying different settings for different types of builds. At the core of Cmake's functionality is the cmakelist.txt files. This script contains instructions that define how a project should be built. The files include information such as which source files to include, which compiler flags to set, which external libraries to link, and which files needs to be installed during the build process. Developers can also define different targets, such as executables, libraries, and test cases with the cmakelist.txt files. This modular approach to configure allows developers to manage large and small projects efficiently. A relatively recent addition to Cmake is the concept of Cmake preset. Presets allow developers to define reusable build configurations for different environments and platforms. This ensures that the entire development team is using the same build settings, reducing inconsistencies between different development and production environments. Preset helps streamline the process of managing multiple environments and simplify the development workflow, especially for large teams working on complex projects. Cmake has excellent support for managing external dependencies. The find_package command allows developers to search for and link external libraries automatically. For more complex cases, Cmake's fetch content module allows dependencies to be downloaded and built as part of the project itself without requiring users to install them manually. This is particularly useful when working with third-party libraries, as it ensures that the correct version of the library is used and reduces the need for manual installation. Cmake provides a range of build system generators that allows developers to generate project files for different build systems, including Make, Ninja, Visual Studio, Xcode, and more. This means the cmakelist.txt files can be used to generate project files for different platforms without the need for modifications. This greatly simplifies the process of developing cross-platform software and allows developers to focus on writing code rather than configure platform-specific build systems. Another powerful feature of Cmake is its support for targeting-based builds. In traditional build system, settings such as compiler flags and linker options are often applied globally, making it difficult to manage different parts of the project that may require different settings. With Cmake, developers can apply settings to individual targets, e.g. executables, libraries test, ensuring that each part of the project is complied with the correct options. This improves flexibility and makes it easier to manage complex projects with multiple components. Cmake supports the integrations of unit testing frameworks such as Google Test, Catch2, and Boost.test. The add_test command allows developers to define automated test cases that can be executed as part of the build process. This enables continuous testing and ensures that the software remains robust and free from regressions as it evolves. Cmake integrates with testing frameworks, making it easier to automate the testing process, ensuring that every change is tested before it is deployed. It supports cache variables, which store configuration options that persist across multiple builds. This is especially useful when switching between different builds environments or when working with multiple developers who need to share the same configuration settings. Cmake can also be easily integrated with continuous integrations or CI and development CD pipelines such as GitHub Action, Jenkins, and GitLab CI. This ensures that software is built, tested, and deployed consistently across different environments, reducing the risk of errors caused by manual configurations. It provides support for debugging and profiling, allowing developers to optimize their software. Developers can specify different build types, e.g. debug, release, rel with deb info to generate builds optimized for either performance or debugging. It also integrates with various debugging and profiling tools such as GDB, Valgrind, and LLVM sanitizers to help identify memory leaks, undefined behavior, and performance bottlenecks. Cmake offers built-in support for installation and packaging, making it easier to distribute software across multiple platforms. The install command allows developers to specify which files should be copied to the system during the installation process. Additionally, Cmake works with package tools like Cpack, which can generate installers or binary distributions for different platforms, streamlining the distribution process. Cmake supports custom build logic, allowing developers to define custom commands and targets. For example, developers can use add_custom_command to generate code, copy files, or perform other tasks as part of the build process. Cmake also supports cross-compilation, enabling developers to build software for different architectures or platforms, such as compiling ARM binaries or an x86 machine. This is particularly useful when developing for embedded system, mobile devices, or other specialized platforms. It has excellent support for modern C++ features, including managing compiler flags, handling standard library dependencies, and detecting available features on the system. This ensures that the code is portable across different compilers and environments. Developers can use Cmake modular approach to manage complex projects, break them down into smaller, reusable modules that can be shared and maintained easily. However, its syntax and configuration files can be difficult for beginners to grasp, especially for those unfamiliar with build systems, making the initial setup challenging. For example, for simple projects, Cmake can be overkill, as it adds unnecessary complexity compared to simpler build systems or just using a basic makefile. Its error messages can sometimes be vague or cryptic, making it difficult to quickly identify and resolve issues, particularly in large or complex configurations. Cmake supports parallel builds, which can significantly speed up compilation times. By using the command Cmake build parallel, developers can take advantage of multi-core processors, allowing the build process to run faster and more efficiently. Cmake also offers various performance optimizations options, including link time optimization or LTO and compiler-specific flags that allow developers to fine-tune the build process for maximum efficiency. Cmake can be integrated with external package managers like Conan and VCPKG to manage the third-party libraries. These package managers automatically download, build, and manage dependencies, reducing the complexity of manual handling external libraries. This ensures that the correct versions of dependencies are used and simplifies the management of external libraries in large projects. Cmake provides extensive logging and debugging options that help developers troubleshoot build issues. By enabling verbose output with the Cmake trace expand command, developers can inspect how variables are expanded and track the execution of Cmake scripts in great detail. This feature is especially useful for debugging complex build configurations or resolving issues with dependencies. Overall, Cmake is a powerful, flexible, and essential tool for modern software development. It simplifies the process of managing across-platform builds, handling dependencies, automating testing, and integrate with CI or CD pipelines. Whether you are working on a small open source project or a large enterprise application, Cmake provides the tools and features needed to streamline the development and deployment process. Its extensibility, ease of use, and broad support for various platforms and compilers make it a vital tool for developers aiming to optimize their build systems and improve their workflow. Cmake is worth considering if you're working on a cross-platform development or managing complex build system. It simplifies the process of generating platform-specific build files like Makefiles or Visual Studio project files, and ensures that your code can be built consistently across different environments. It supports a wide range of programming languages, integrates well with version control system, and has a robust community behind it. While this is a learning curve, especially for beginners, the benefit of automating and streamlining the build process, especially in large projects, often outweigh the initial setup efforts. If you're working on a project that needs to run on multiple platforms or require complex dependencies, Cmake can save a lot of time and effort. Thanks for watching. Don't forget to like and subscribe to see more content like this.